Bismillahirrahmanirrahim. My name is Sutpa Abdul Basit from the Department of BS Physics. Today, my topic of presentation is MXene. Let's look into the introduction of the topic. Transition metal carbide, nitride, or carbonitride are a new type of two-dimensional materials whose rich elemental composition and flexible structure tunability endow them with unique physical and chemical properties. General formula of MXene is given in this expression. M stands for transition metal, X stands for carbon or nitrogen, T stands for surface functional groups, X stands for number of surface functional groups. MXene are obtained by selectively etching atomic layers of A in the mix phase, where A is a group of elements from group 3A to 7A. MXenes show hexagonal symmetry in which transition metal atoms are arranged in close interstitial position. Most MXenes show metallic or narrow bandgap semiconductor properties. They also show unique electronic properties such as semimetallic state, insulating state, ferromagnetism, and antiferromagnetism, etc. MXenes also show unique optical properties and shown great potential in the field of optical functional materials. Preparation methods of MXenes. In mix phase, MX bonds are mainly covalent bonds and ionic bonds, and the bond strength is high. The AA bonds are mainly metallic and relatively weak. Therefore, A atom layers has highest reactivity and is easier to be etched. Main methods include HF etching, fluoride salt etching, and fluoride-free molten salt etching. First method is HF etching. It is the earliest method to prepare MXene. In 2011, Chinese scientists found that HF could selectively etch as a aluminum atomic layer in MXene to form accordion shape with van der Waals forces between the layer. The formation of accordion-like structure was mainly attributed to exothermic nature of reaction and release of hydrogen during removal of aluminum atom. For the concentration and etching time, HF are the important factor affecting the preparation of a magazine. Higher HF concentration could shorten the etching time and improve the preparation efficiency of a magazine. Higher HF concentration, more defect is obtained a magazine nanosheet, resulting in reduced mechanical and conductive properties. Advantage of HF etching is it is a relatively easy and simple process and occur at low temperature. Disadvantage of HF etching requires further treatment with organic reagent to obtain few layered MXene. HF is highly corrosive and toxic, posing environmental risk and susceptible to defects. Fluoride etching. It is a method that uses fluoride salt and acid as an agent to generate HF. To prepare a magazine. In 2014, it was first used HCl and lithium fluoride solution to etch a magazine at 40 degrees centigrade to prepare a magazine. During the process, lithium ion was inserted into accordion shape a magazine layer to expand the interlaying spacing and could be directly layered into single layered or few layered magazine nanosheet through subsequent ultrasonic or shaking treatment. The M-magazine conductive clay prepared by this method had high electrical conductivity, strong plasticity, and could be bent into complex shapes. Besides lithium fluoride, other fluoride salts also have been used as agents. Interlamellar spacing and surface structures of a magazine could be tuned by changing the type of fluoride salt. Mixing fluoride salt with other acids could also help to prepare a magazine. For instance, if we replace HCl with H2SO4 can improve reaction efficiency and therefore sulfide functional groups on the surface of prepared MXene. Advantage of fluoride etching is that MXene from this method have larger sheet sizes and fewer defects. Disadvantage is the presence of H positive and fluoride negative ion solution still releases H2F to some extent, impacting the health. Third method is fluoride free molten salt etching. Transition metal halides can react with aluminum atomic layer of max phase in molten state to prepare MXene. For this, zinc chloride NaCl KCl mixed with molten salt system to etch MXene under nitrogen atmosphere. During this process, zinc reacted with aluminum atoms in MXene and weakly bonded aluminum atoms were transformed into aluminum um, ion. Reduced zinc atoms then occupied the position of aluminum atomic layer to form MXene. Finally, excess zinc chloride etched the zinc atom and eventually generating a MXene compound. Studies have shown that the ratio of zinc chloride has significant impact on qualities of final products since process is fluorine free and non-aqueous. The MXene surface obtained by zinc chloride etching was full of chlorine functional groups instead of oxygen, fluorine, or hydroxyl functional group. The types and properties of surface functional groups of MXene can be changed by adjusting the type of molten salt. We can use copper chloride, cuprous bromide, or cuprous iodide mixed molten salt system to HMXene to prepare. By adjusting the type and mass of ratio, functional group on the surface of prepared MXene could be adjusted and controlled. Advantage of this method is that it is chemically safer and can replace or eliminate surface functional groups with molten inorganic salt. Also provides a way to design and prepare MXene with specific surface functional groups. Disadvantage is the method requires high temperature treatment with a large amount of salt. It is not easy to extract MXene from the product. Application of MXene. Following are some application of MXene in various fields. First is biological sensor. Photoelectrochemical response is a new technique used for detection and analysis of gases and organic compounds by amplifying photocurrent signals. Light capture ability and interface redox reaction are the key to signal amplification. SACs are excellent biosensing catalysts have the active sites with same coordination structure corresponding to the unique enzyme active sites and unique etheric electron cloud distribution which is conductive to signal recognition and amplification. In addition, two-dimensional MXene in combination with SACs with large interface, excellent conductivity, and easily adjustable electronic structure have been investigated for biosensing systems. Single iron atoms to heterojunction of MXene and cuprous oxide to accelerate the interfacial redox reaction of p-type semiconductors. The introduction of iron nitride side changed the absorption of oxygen reduction intermediates on cuprous oxide. In addition, the insoluble enzyme precipitation induced by iron SACs inhibited PEC signal, suggested that peroxidase could be detected by iron SACs. Furthermore, the addition of acetylcholine citrate regulated the enzyme activity of iron and amplified the photoelectric signal, resulting in a low detection limit and a wide linear range for organophosphorus pesticides. Moreover, SSCs on MXene show promising application in cancer diagnosis. For the clinical detection, RNA 187 in triple negative breast cancer tumor tissue was positively correlated with the concentration. Second application is gas sensor. As a raw material for many industrial production, ammonia is one of the common industrial pollution and is harmful for the environment and human body. Thus, there is an urgent need for fast and convenient ammonia sensor. Single layer MXene was synthesized by sodium fluoride and hydrochloride etching without the addition of any single atom for the detection of ammonia at room temperature. Not only ammonia, single-layer MXene also responded to other seven gases but had the highest selectivity for ammonia, which was 4 times more responsive than the next highest. However, both the multi-layer and the addition of metallic acid sites exhibited higher response to ammonia than single-layer MXene at the humidity of 40% relative. The response sensitivity of silver plated MXene to ammonia was the highest which was ever attributed to the affinity between the intercalated water and ammonia. However, excess water would hinder the adsorption of ammonia at the active site. With the strong adsorption or capacity for ammonia, silver nanoparticles first absorb ammonia and then the absorbed ammonia diffuse to MXene, increasing the response resistance. Trimethylamine has a strong smell of ammonia and is toxic to human body, which is urgent to be detected with a high sensitivity sensor. Now injected platinum signal atom into a magazine, greatly improving the sensitivity and selectively for of a magazine for triethyl T detection. Theoretical calculation indicated the reduced detection level was due to chemical sensitization of platinum atom and the strong absorption between platinum and T. Through NaCl molten salt aging, an NO2 sensor was synthesized with a low detection limit. Since amexine is easily oxidized in wet environments, more efforts are needed to obtain amexine-based assay sensor with better performance. Third application is supercapacitors. Supercapacitors are another type of energy storage devices which store energy through charge accumulation and reversible redox. Compared with batteries, supercapacitors have a faster charge and discharge rate but a faster decay of energy density. Insert aluminum ions into M-magazine providing a specific capacity of 175, and due to increased layer spacing, more lithium ions were stored for subsequent ion exchange. V3CrC3TX was synthesized by replacing the part of V atom with chromium atoms, which increased the absorption capacity for zinc ion. The synthesized zinc anode material based on presented increased capacitance and discharge potential with high surface charge density and foldability, indicating high compactness in the use of flexible portable power supplies. Fourth application is image sensor. The principle of sight is depicted as follows. The eyes convert light to image and color signals for processing by the brain. The retina, a membrane composed of arrays of photoreceptor cells, converts the light beam into nerve pulses which transform to the synaptic potential and transmit to the brain. Eventually, the brain reconstructs the visual image continuously. A magazine was employed as an electrode for photodetector array for image sensing. Light absorption can be achieved through resonance enhancement in the near-infrared band. The photodetector array enables 1250 pixel image sensing with a response of 80.88 negative W negative, a specific detectivity of 3 raised to the power 12 joules, and a linear dynamic range of 82 decibel in the near infrared region. This work provides a solution for an image sensor of high resolution and pattern controllability. The transistor array based on MXene can be prepared with patterning techniques such as direct writing and inkjet printing. They have drawbacks of low pixel resolution. With a transistor-based detector in each pixel, the MXene image sensor has been fabricated with conventional lithography protocols over a 4-inch wafer, which shows high compatibility with SI technology. The M-magazine stacking with other photosensitive materials such as metal sulfide selenides leads to the regulation of detection wavelength. For example, PDSE2 may extend to the near infrared for thermal imaging. High performance optoelectronic devices require significant absorption coefficient, long diffusion length, and adjustable band edge width. High quality photosynthetic materials are among the research hotspot of the next generation optoelectronics. Early image sensors are developed based on light intensity. Future opportunities remain for recognizing color by speculating the wavelength of illuminated light. Fifth application is organic waste water treatment. Recently, Fenton-like systems have been widely explored and applied for the removal of organic matter from wastewater. Two-dimensional MXene-based materials exhibit excellent absorption and catalysis capacity for organic pollutants removal, which has been reported widely. However, there is no summary on the application of MXene-based material in phantom-like system for organic matter removal. In this review, four types of MXene-based material were introduced, including two-dimensional MXene metal complex, metal oxide complex, and three-dimensional carbon material complex. In addition, the phantom-like system usually consists of adsorption and degradation processes. The oxidation process might contain hydrogen peroxide or persulfate oxidants. Properties of MXE. The M-magazine consists of the transition metal nitride and carbide. It had good electrothermal, mechanical, and chemical properties. The structure, composition, surface, and interior chemistry of a magazine can determine their physical and chemical properties. Unlike other two-dimensional materials, the electric properties of a magazine rely on M, X, and their surfactants. Because of the defects in their surfactants, the synthesis process affect their electronic properties. MXenes have optical properties such as light absorption, emission, and scattering. MXene displays surface plasma modes among the visible and near infrared range and exhibits strong absorption in ultraviolet range. The structure M excites and surface termination are main factors influencing their optical properties. Studies on the mechanical properties of MXene have used monolayers of MXene. They show high tensile strength, indicating high fracture toughness. MXenes show good hydrophilicity, surface flexibility, high metal conductivity, high compatibility, and other characteristics with an extensive scope of possible uses included in nanomedicine, biosensor, biological imaging, antimicrobial therapy, and therapeutic diagnostic. Conclusion and outlooks. A magazine-based optical functional material have been widely used in the field of photothermal conversion and photocatalysis and have achieved certain achievement and progress, but there are still some keen scientific and technical bottleneck problems to be solved. First, using lithium fluoride hydrochloride solution to etch max phase is still the mainstream method for preparing a magazine. Researchers are suggested to develop fluorine-free, safe, and efficient method for preparing amexine and then develop new anti-oxidation amexine to expand their application in the field of optical functional material for wider application. Researchers have recommended to systematically study the factor affecting the optical properties of a magazine, master the laws of light absorption, ability of a magazine under different surface states, clarify the changes in optical properties of a magazine under different shapes with different atoms, and realize the better application of a magazine in the field of optical function. Third point is it is worth considering carrying out systematic research on biocompatibility such as genotoxicity, chronic toxicity, and carcinogenicity, biodegradability, pharmacokinetics, biodistribution, immunogenicity of a magazine-based photothermal conversion materials, which is particularly important for broadening its application in photothermal therapy. Fourth point, researchers are suggested to clarify the constitutive relationship between the type of a magazine surface functional groups, the number of a magazine layer, and its photocatalysis material by adjusting the surface functional group of a magazine and number of a magazine layer. It is of great significance to promote wider application of a magazine and a magazine based material in the field of photocatalysis. Thank you very much. This is my presentation.